Hello student, welcome to Newton Gate Academy where we make your dreams come true. Today we are going to discuss a chapter in chemistry, atomic structure. One of the most important topic is atomic emission spectra, where an atom absorbs energy, their electron move to higher energy level. And this electron loses energy by emitting light and when they return to the lower energy level. And this relation was mathematically proved by Rydberg through its Rydberg formula that helps in measuring the spectral energy of electron transmission, and it applies to hydrogen as well as any series of atom. Here are the few series where which states in which region electrons are there, such as if we are talking about Lyman series is about the UV region, which is ultraviolet region, whereas Balmer series is about the visible range where your initial N value is 2, whereas in the case of Lyman the initial N is 1. In the same way, for Paschen the N value is 3. In atomic model, one of the very important model is Bohr's model of atom. According to Bohr, unless and until electron remain in its own orbit, its energy is conserved. Only when electron jump from one orbit to another orbit, it loses or gain energy. And here energy is equals to h nu, where h is a Planck's constant. So by Bohr's formula, we can calculate energy from any orbit. Here is the formula by which we can find the energy of nth orbit, where 2 pi square m e square by h square is a constant value, where m is the mass, e is the charge of the electron, and h is the Planck's constant, which is a constant value that is 13.60 eV per atom. To clear the concept, let's solve the question. Find the wavelength of the electromagnetic radiation that is emitted from an electron relaxes from N3 to N7. According to Rydberg formula, we know that 1 by lambda equals to RH, which is the Rydberg constant, into 1 by N1 square minus 1 by N2 square, where N1 is the initial line or initial state and N2 is the final. And our Rydberg value is 109677 centimeter inverse. So if I solve this, then I will first convert the centimeter inverse into meter, and then the value of Rydberg will become 1.09677 into 10 to the power 7. Whereas in the place of N1 I will put 3 and in the place of N2 I will put 7. And by solving this, we will find that lambda is 11.402 into 10 to the power 7 meter. Let's move to another question. A hydrogen atom initially in its ground state, that is N is 1, absorb a photon and ends up in N equals to 4 level. What is the amount of energy absorbed by the electron in joules? So here we know that the initial state N1 is 1 and the final state N2 is 4. So according to the formula which I have mentioned in the previous slide, that E equals to minus 13.6 into 1 by Nf square minus 1 by Ni square, where Nf stands for final state and Ni stands for initial state. Now if I convert 13.6 eV into joules, it will give me 2.18 into 10 to the power minus 8. So by substituting the value in the equation where Ni is 1 and Nf is 4. So by solving in that way, we will find that the answer, that is the energy, is 2.04 into 10 to the power minus 18. Next question. A photon is emitted as an atom makes a transition from N4 to N2 level. What is the frequency, wavelength and energy of the emitted photon? So, according to the question, our initial orbit is, that is Ni is 4 and final is 2. So, if I apply the basic rule of energy, that is E equals to h nu, where nu is the frequency, then we can actually calculate the frequency. So first, before calculating the frequency, we have to first calculate the energy. So by applying the rule E equals to minus 13.6 into 1 by Nf whole square minus 1 by Ni whole square, we will calculate the energy, which is 2.55 eV. Then substituting this value of energy in the formula E equals to h nu, we will calculate the value of frequency, that is nu. And the frequency comes 6.15 into 10 to the power 14 Hertz. Then when we have calculated the frequency, we can easily calculate the wavelength, that is C equals to F into lambda, that is frequency into lambda, and lambda is my wavelength, so that will come C by frequency, that is speed of light by frequency, and which comes 4.875 into 10 to the power minus 7 meter. The final question is, Lyman series of line in the emission spectrum of hydrogen corresponds to transition from various excited states to the n equals to 1 orbit. Calculate the wavelength of the lowest energy line in the Lyman series to the 3 significant figure. We all know the Rydberg formula, that is 1 by lambda equals to RH into 1 by N1 square minus 1 by N2 square. We know that in Lyman series, my initial state, that is N1 value is 1. So if I substitute the value of N1 as 1 and N2 is already given as 4. So by that we will calculate the lambda as 8.228 into 10 to the power 6 meter inverse. After calculating the lambda, we can also calculate wave number. Wave number is basically reciprocal of lambda. So if we do divide 1 by lambda, that is 1 by my wavelength, we will get the wave number. Thank you for watching this video. If you like this video, do like, share, subscribe our YouTube channel.